Write the molecular formula of the following. Before we start this, let's just revise our functional groups. We know if there is an OH, it is an alcohol. So we write this OH is an alcohol and all of them end with an OL. Then if it is a COOH, it is a carboxylic acid, and all acids they have end with OIC. Then we have CHO, it's an aldehyde, and aldehydes end with al, like methanol, ethanol. If it is CO, it's ketone, and ketones end with O and E. If there's a double bond, they are alkenes, and alkenes end with E and E. If it's a triple bond, they are alkynes, and alkynes end with Y and E. Now for this first one, it's given methane. Meth means one carbon, ane means it's an alkane. So one carbon alkane, the formula is CH4. Now next is methanol. Now because it is OL all, it's an alcohol, so it is OH. And meth means one carbon. It's a one carbon alcohol. So we have OH, alcohol, one carbon alcohol. So CH3OH will be methanol. Now next is methanol. Now because it is al, it is an aldehyde. So CHO. And meth means one carbon. One carbon aldehyde would be CHO. The carbon is already taken up, so H. So this would be a one carbon aldehyde. Next one is OIC. Oic means acid. Acid is COOH. And this is one carbon acid. So for one carbon acid, we have COOH because it is an acid. The hydrogen carbon is already taken up. So you have one carbon acid, Methanoic acid. This is ethane. Ane means an alkane. And we have here, it's a ethane, so two carbon alkane. Two carbon alkane will be CH3, CH3. Next here we have ethene, ENE, that means it has got a double bond, and it will be two carbon. So we have two carbons here with a double bond. So you have 1, 2, 3, 4, 1, 2, 3, 4. So hydrogen, hydrogen. So ethane would be CH2, CH2. Just notice the difference. This is ethane and this is ethene. Both are two carbons. One has got a double bond, one does not have a double bond. Now next one is ethyne. Ethyne, Y-N-E, means a triple bond. It means two carbon with a triple bond. So we write two carbons, and now we're going to put triple bonds here because it's ethyne. Now for this carbon only one hydrogen we can attach, and here too only one hydrogen. So now it becomes CH-CH. Now CH-CH is a triple bond and it's ethyne. Next one, ethanoic acid. Oic means acid, it means COOH. Ethanoic means it's a two carbon acid. So first we have to write, it's an acid, so we write COOH. It's a two carbon acid. So one carbon is already there in the functional group. We have to put another carbon here. So CH3COOH will be ethanoic acid. Now for next is ethanol. Ol means alcohol, OH, and eth means 2 carbon alcohol. So we got to write a 2 carbon alcohol. So we write OH means it is an alcohol, and 2 carbon. So we have to put 1 and 2 carbon. The terminal carbon always has 3 hydrogens. So CH3, CH2OH will be ethanol. CH3, CH2OH. You can also write it as C2H5OH. Now next is ethanol. Aldehyde, CHO. This you need to remember. Then eth means 2 carbon. It's a 2 carbon aldehyde. So I write CHO, because it is an aldehyde, it's al, and I have to put 2 carbons. 1 carbon is already there, so I got to put another carbon here. It's a terminal carbon, so CH3. Now for propene, ENE means it has got a double bond. Prop means it is 3 carbon. So I have 3 carbon, 1, 2, 3 carbon with a double bond. So I need to put anywhere I can put the double bond. I'll put it here. Now see how many hydrogens would go. 1, 2 are already here. 1, 2, 3, 4. 1, 2, 3. This can take only 1. You can write it up or you can write it down. So 1, 2, 3, 4. So I have H. So this will be my propene. So it will be CH2, CH, CH3 will be propene. I can also write it as C3H6. And if you can recollect, alkenes had a general formula CnH2n. Next is propanol. Ol means OH and prop means 3 carbon. OH with 3 carbons. So let me put my 3 carbons. 1, 2, 3. The terminal carbon has got always 3. Then we have 2 and 2. This is propanol. I could also write it. There are 3 carbons. And if you see the hydrogens, 3, 4, 5, 7 hydrogens, OH. I write the OH separately. I don't include that. Add up the hydrogens. So I know it's OH, it's propanol. Next is propanone. ONE means a ketone. And prop means it's a 3 carbon ketone. 3 carbon ketone. So I write my ketone. This is my functional group for ketone with 2 arms on either sides. And I have right here carbon, here carbon. This will be CH3, CH3. So if you see here, this is a 3 carbon ketone. Next is propanal. Al means an aldehyde, so it is CHO, and prop means 3 carbon aldehyde. So let me write CHO, 3 carbon. I need to add 2 more carbons. 1, 2. This will be CH3, terminal carbon, CH2. So this would be propanal. I could also write it as C2, H5, and CHO. I don't add up the oxygen, hydrogen, and carbon in the rest because I can make out that is CHO, the functional group. Like you do not write it C3 because 2 plus 1, 3, 5, H6O. Then you cannot make out the functional group. This is not the way of writing it. You need to write with the functional group separate. Then we go to propine. YNE means it has got triple bond. Prop means it's a 3 carbon triple bond. So I put my 3 carbons here. 1, 2, 3. And I need to put a triple bond. Anywhere I can put it here or I could put it here. 1, 2, 3 I'll put it. I got to put my hydrogen. This carbon is already attached 3, only 1 available. The middle carbon, this middle carbon is already full. The 4 arms are full. It cannot attach anymore. This last carbon, so this is your propine. And if you see, it is C3, there are H4. If you just recollect the general formula, Cn, H2n minus 2. That is propine. This is the formula for propine. Now for propanoic acid. OIC means it's an acid, so functional group COOH. So let me write here COOH. And propanoic, so 3 carbons. So 1 carbon is already there. I need to put 2 more carbons. So it will be CH3, terminal carbon CH3, CH2. So this is propanoic acid. For next, butane. And if you see, this is YNE, means it's alkyne. So it has got triple bond. And but means it has got 4 carbons. So it's a 4 carbon alkyne. So 1, 2, 3, 4, and it's got a triple bond. You can put the triple bond in any place. You can put it here, or you could put it here, or you could put it here. They all have different names, but to make things easy, I will just put it always in the first place. So let us see the first carbon, how many hydrogens can it hold? It already has 3 bonds occupied. It can hold only 1 more. This middle carbon now has already 4 arms occupied. It cannot hold any more. So the next carbon has got already 2 arms occupied. It is 1 and 2. It can hold 2 more. 1, 2. So hydrogen and hydrogen. And this last has got 1 arm only occupied, and it can hold 3 more. So I put hydrogen, hydrogen, hydrogen. So now butane will be here. I'll put CH, C, then is CH2, CH3. Let me do that again. So it is CH here, then this is C, then the third is CH2, and the last is CH3. This is butane. And if you write it here, there are 4, and here the hydrogens are 1, 2, 3, 4, 5, 6. So 6. It will have the general formula CnH2n minus 2. This is the formula of butane. 4 carbon with triple bond. Then with butane, ane means alkane. Alkane with 4 carbon. So I have here my 4 carbons, 1, 2, 3, 4, and then you have the hydrogens, and I'll straight on write it will be C4H10. This will be butane. If you put the hydrogen here, you will find there will be 10 hydrogens attached. Next is butanoic acid. Oic means COOH. So I'll write that COOH. And butane, so 4 carbons. So 1 carbon is already there. So 1, 2, 3, and the 4th carbon. So we'll put CH3 here, CH2, CH2. So this will be butanoic acid with 4 carbons. Last is butone. One is ketone, so it has got CO with 4 carbons. So here we have C double bond O, and we need to add 4 carbons. You can put 2 on the side, you can 3, 1, or 2 on one side, 3, whichever way you want. But what's important is the CO group should be in the middle. So here this can attach 3 more. So 1, 2, 3, 4, 1, 2, 3, 4, and you go on. And you see the formula will be the first carbon has got 3 hydrogen, then we have the CO group. Then this next carbon has got 2 hydrogens, and the third carbon has got 3 hydrogens. So this is butanone. Butanal, aldehyde CHO. But means 4 carbon aldehyde. So let me write a 4 carbon aldehyde. First I write CHO, the functional group, and it has to have 4 carbons. 1 carbon is already there, so 2, 3, 4. CH3, CH2, CH2. This is butanal. The next is butene. In means it has got a double bond. But 4 carbon double bonds. So 1, 2, 3, 4. Now the double bond can be in any place. I will always put it in the first place to make things easy for you, and then we can learn how to put it in different places and see how the molecular formula changes slightly. So we have butene. So the first carbon now here, we'll have 4 arms. So 2 arms already occupied. So here 3, 4. The second one has got already 1, 2, 3 occupied. It is only one mode is available. So we'll put here hydrogen. Now for the next one, 2 arms are occupied, 2 are available. So again hydrogen. And for the last one, 1 are occupied, 3 more available, and we will put hydrogen here also. So when it comes to now butene, the formula will be the first carbon has got 2 hydrogen, second has got 1, then it has got 2, and then it has got CH3. But you could also do it in an easier way. You know it is an alkene. And alkene, the general formula is CnH2n, which you must remember. In this case, a number of carbons are 4, so it will be C4H2 into 4. And that will be 8. So it was C4H8 is also butene. Now, butanol, OL, so alcohol. And but means 4 carbon alcohol. So first we write OH here, because it's a functional group. To this OH, I got to attach 4 carbons because it's a 4 carbon alcohol. So 1, 2, 3, 4. The terminal carbon will always have 3. Then we have H2. This is easy because there are no double bonds. When there are double bonds, you need to write the structure like we did in butene. So this is our butanol. If you want to put it all together, you will find that it has got 4 carbon, and the hydrogens are 3 plus 2 plus 2 plus 2. So that would be 9. And you will put here OH. Of course, I'll put it in red just to show you it's an alcohol. Now, next is butanoic. Oic, by now you know it's an acid. And pentanoic. Pentanoic means a 5 carbon acid. So, first we write COOH because it is oic, it is acid. And to this we add 5 carbons. 1, 2, 3, 4, because the 5th carbon is already there in the functional group. We have CH3, CH2, CH2, CH2. This is pentanoic acid. Next is pentane. Pentane means 5 carbon. So 1, 2, 3, 4, 5. And to that we keep adding our hydrogens. And if you do that, you will find the formula will be, if you add up, it will be C5H12. There will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 hydrogens. So this is your pentane. For pentanol, all alcohol, OH, so I'll put OH, and pent means 5 carbons. So I've got to attach 5 carbons. 1, 2, 3, 4, 5. CH3, CH2, 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 and CH2. If I were to put all together, this will be C5H. This would be pentanol. Now, pentanone. On means ketone. CO. 5 carbon ketone. So, first we write the ketonic group. It's always in the middle, the ketone. This is the only functional group that is in the middle. Now, you've got to arrange your 5 carbon any way that you want. You could put 2 on this side and 3 on this side 2, 2, or this makes 5, or you could put 1 on the side, the other 3 on the other side, whichever way you want. So this would be CH3, this would be CH2, CH3, no, CH2, it's not terminal, CH3. So this would be now pentanone. You could also write it like this, C2H5 on one side, then there was CO, and on the other side was C2H5. That would be pentanone. Pentine, YNE, means triple bond. Pent is 5 carbon. So we've got to make a long line of 5 carbons now. 1, 2, 3, 4, 5. And we need to put a triple bond. We can put it anywhere, but for now, to make things easier, we'll put it in the first place. So the first carbon now can hold only 1 hydrogen because 3 arms occupied. The second can hold none. So it has got like this, it's already occupied. This carbon can hold 1, 2, 3, 4. The next carbon can hold now 1, already 3, 4. And here the last carbon, 1, 2, 3, 4. Let's put the hydrogens. So we have all the hydrogens here, 1, 2, 3, 4, 5, 6, 7, and the 8 hydrogens. So the formula for this, if you want to write it at length, will be CH, C, CH2, CH2, CH3. But this is not what we write usually. We write 6, 5, and we saw that our H were 8. Now next, pentanal, al, CHO, and pent means 5 carbon aldehyde. So we write a CHO here, and we put 5 carbons. 1 carbon is already taken up by the functional group, so we need to add 5 more. 1, 2, 3, 4 more, not 5 more, 4 more. So CH3, CH2, CH2, CH2. That would be pentanal. Now for hexanol, al, CHO, 6 carbon. So we have the CHO, always write the functional group first. Now we are left, 1 carbon is taken up, we need to write only 5. 1, 2, 3, 4, 5. CH3, CH2, 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 and CH2. If you condense this formula, it will be C6, H11, and you have CHO. This would be a better way of writing it.